In this video, I'm going to go through question 18 from the 2014 exam. Here we're given a payoff table, and we have to determine which of the listed pairs of strategies is a Nash equilibrium point. This question's worth 3 marks, so the intent is to work through it quickly without showing too much working. For the purposes of explanation, I'm going to show a lot more than what you actually have to show on the exam. In the end, all you have to really do is just write down the answer. The important thing to remember is what a Nash equilibrium point is. A pair of strategies is a Nash equilibrium point if no player can change their move and put themselves into a better position. I'm going to duplicate the table so that we can see where all the working comes into play. So, for part A, players 1 and 2 both make move 1. That puts us in this position here, where player 1 has a payoff of -2, and player 2 has a payoff of -1. So now we have to ask ourselves, can either player improve their position? If player 1 changes their move from move 1 to move 2, they've gone down here and they've improved their payoff from -2 to -1. Since there is a way for a player to improve their position, that means that this is not a Nash equilibrium point. So let's move on to part B. For part B, player 1 makes move 1 and player 2 makes move 2, which puts us in this position. Player 1 has a payoff of 2 and player 2 has a payoff of -2. If player 1 changes their position, we go from here to here, and player 1's payoff has gone from 2 to -2. So they've made their position worse. So far that's fine, so we'll check the same thing for player 2. If player 2 changes their move, they go from here to here, and they've improved their payoff from -2 to -1. Since player 2 has the opportunity to improve their position, that means that this is not a Nash equilibrium point. Let's check part C. Here, player 1 makes move 2, and player 2 makes move 1. That puts us in this position here. If player 1 changes their move, we move to this point here, and player 1 has gone from a payoff of -1 to a payoff of -2. That puts them in a worse position, and so that's okay so far. If player 2 changes their move, they go from here to here, and their payoff is once again decreased, this time from 0 to -1. So, no player has the opportunity to improve their position from here, which means that this is a Nash equilibrium point. Let's continue and check part D, because there is the possibility of more than one existing. Here, players 1 and 2 both make move 2, which is this position here. If player 1 changes their move, they've gone from a payoff of 1 to a payoff of 2. That's an improvement in position, which excludes the possibility of this being a Nash equilibrium point. So, we can finish up the question by writing C only.